In this video, we're going to introduce the spring force and solve some basic problems using this concept. Whether we are dealing with a mattress or pogo stick, the spring force will be at play whenever a spring is involved. The spring force is the force exerted by a compressed or stretched spring upon any object that is attached to. According to Hooke's law, the spring force is equal to negative kx, where k is the spring constant and x is the displacement from the spring's equilibrium position. To get a better understanding how this formula is derived, let's look at this diagram. So try to recall a time when you play with the spring. Envision yourself stretching the spring as far as you can without breaking it. Now let go of the spring and think about which way the spring traveled. If you say that the spring traveled in the opposite direction of your initial stretch, then you are correct. Even if you compress the spring, you will observe the same phenomenon. This is the reason why we have a negative sign before our spring constant. The negative sign means that the spring force is always in the opposite direction from the displacement we gave it. Additionally, this is the reason some refer to the spring force as a restorative force, because it is trying to restore the spring back to its equilibrium position. So when you look at the diagram, it should make sense that the spring force will point in the opposite direction of its displacement. So some of you still may be confused about what is the spring constant. The spring constant K is a number that tells how stiff the spring is. This constant depends on the material the spring is made out of, so this number will vary from spring to spring. Typically in your introductory physics courses, the type of problems you will encounter will either give you the spring constant or make you solve for it. So now that you have a solid understanding about the spring force, let's look at an example. This problem states a spring that is at rest is attached to a wall at its left side and a block at its right side. The spring constant is equal to 12 newtons per meter. The block is pulled towards the right and the spring is displaced from its equilibrium position by 0.4 meters. And the problem asks us, what is the spring force exerted on the box? To solve this problem, we can use the spring force formula we just learned. So we're given that the spring constant is 12 newtons per meters and that the displacement is 0.4 meters. So we can just plug in these two numbers into the formula and get our spring force. So the spring force is equal to negative 12 newtons per meter times its displacement, which is 0.4 meters, and this will give us negative 4.8 newtons. This means our spring force will be pointed towards the left. And this makes sense because we mentioned earlier that the spring force will point in the opposite direction of its displacement. So in conclusion, the spring force is pointed in the opposite direction of its displacement. And using Hooke's law, we can say that the spring force is equal to the negative spring constant times the object's displacement. Thank you for watching this video and hope to see you next time.